Good morning from Chicago. This is Tim Stewart. I am president at Visual Decisions, and we are here today to talk about MES, the Industrial Internet of Things, or IoT, and when to choose which solution. At Visual Decisions, we've been in the business of utilizing information from the shop floor to improve continuous improvement since about 2002. We help our customers combine the smart factory with the lean factory to drive improvements to cost, throughput, and quality. Our customers have seen dramatic improvements such as 30% increases in OEE, 50% scrap reductions, and much more. But just like wearing a Fitbit won't automatically make you thin, implementing technology for Industry 4.0 won't automatically make the business better. The culture of the organization and the business processes must be adapted to take advantage of the new capabilities to drive real improvements. That's why we have a unique approach to work with our customers to adapt processes to take advantage of the new capabilities and help establish a true data-driven manufacturing culture. As a quick procedural note, if you have questions during the presentation, please enter them into the Q&A. I'll try to get to them at the end of the webinar. I actually do have a hard stop at 10:30 Central Time this morning, so if there isn't time for questions at the end, I'll reach out to the person that entered the question into the Q&A and follow up with them individually. Thank you. So the goals for today are, what are the key differences between MES and I-IoT? What are the strengths and weaknesses of each? And how do I know when to use which system? So to get started, we'll take a quick look at the general system definitions. MES, or manufacturing execution systems, are used in manufacturing to track and document the transformation of raw materials to finished goods. They provide information that helps manufacturing decision makers understand how current conditions on the plant floor can be optimized to improve production output. It works in real time to enable the control of multiple elements of the production process, and planning, inputs, personnel, machines, etc. And it actually has a pretty broad footprint within the manufacturing plant. And as you can see here, there are multiple kind of definitions depending on the vendor. And so we're looking at a couple of different MES models. Here's another MES model from a different vendor that actually has a few more core modules to it. And it's organized into production, inventory, quality, and maintenance, which is fairly typical actually. And here's another one that lays things out into planning, a laboratory information management system, a historian, and then kind of the core traditional modules. And then there's the original MESA 11 model, which is the Manufacturing Execution System Association, I think, and details out what are the core modules that have historically been a part of MES, including operations sequencing, resource allocation, dispatching, performance analysis, etc. And where that usually fits is kind of in this middle layer here. So this is labeled manufacturing operations management. It's very often labeled manufacturing execution system as well. A lot of that just depends on which vendor you're talking to. But it kind of sits in between the business systems up at the top, such as ERP, and then the actual data collection systems, such as SCADA, or even at a lower level, the sensors and instrumentation and so forth itself. So as a whole, an MES system is a broad suite of solutions that fits together underneath one banner that is used in a wide variety of industries to help manage and control the manufacturing process. So IoT is a much newer kid on the block here, and there's broad agreement on the concept, How it is implemented in different platforms varies widely, though. So, as a broad stroke, the Internet of Things, or IoT, describes network of physical objects, things that are embedded with sensors, software, other technologies, for the purpose of connecting and exchanging data with other devices and systems over the internet. And over time, a lot of things that have been considered separate initially are now considered to be part of IoT, such as a lot of sensors and analytics and embedded systems and things like that are all part of that banner right now. For our purposes today, we're going to be discussing IoT or IIoT software platforms, such as the ThingWorx system sold by PTC. And these platforms consist of a lot of different components, but some of the primary ones, if you look at data collection from different devices and the flexibility of connecting to just about anything as the Internet of Things would expect, being able to route that data and persist that data, event processing, communication, development environments, mashup or user experience or UI builders, machine learning or AI systems are often built into these platforms. Having widget libraries that you can utilize out of the box, basically to help you build an application very quickly, and then highly extensible API so that information can be brought into or out of the system very easily. And typically, these systems ship with very little out of the box functionality. The idea is that they provide the complete toolkit to build any application within the sphere of the industrial Internet of Things, which is an entirely fuzzy term that encompasses just about anything if you ask the right person. So what are the primary strengths and weaknesses of each approach? For the strengths on the MES side, MES has been around for a long time now. It has decades of development and refinement at customer sites with the feedback loop back to development to really hone in on what is the functionality that's going to provide benefit to manufacturing companies. So it's very well established functionality, very well established data models. There are existing integrations between, for instance, an MES system and SAP or Oracle or JD Edwards or things like that. And a lot of those things can be somewhat out of the box. Integrations are never completely out of the box because every system is generally implemented differently at different customers, but the integration is there already. There's a broad suite of solutions, as we saw on the other slide, depending on which vendor you pick. There could be a number of different built-in functions within there. Another key is that it's built to act as a system of record. So if you're in, for instance, a validated environment within, pharmaceuticals or something like that, or if you're in food and beverage and you have stringent track and trace and genealogy requirements for your business, an MES system is extremely valuable for those. And then it's built so that it can be a common system across the different sites, so that the fundamental infrastructure for manufacturing systems can be the same across different sites. And we'll see that again soon. On the IoT side, it's generally a more modern architecture. It's almost infinitely flexible because it's a platform. You can really build just about anything that you want with it. It's built for connectivity. So the very idea of it, the very conception of it is that it can connect to anything that's out there. It's built as a hub for the shop floor. It doesn't look to own the data. So it can be the center of different best-in-class solutions that you may already have out on the shop floor. And so then it can also very easily coexist with those other systems. Some of the primary weaknesses. MES typically has a more rigid structure. And so, you have to find the one that really fits your manufacturing environment. can be a longer implementation time. And partially because of that, it's generally more expensive to buy and implement. And it can really be overkill if you have simpler needs. I mentioned that it's something that can be a common platform across the different manufacturing plants, but very often the different manufacturing plants have different ideas of what they want. And when you try to implement the MES as a common solution in a common way across all of your different manufacturing plants, it can be very challenging. And so that has a tendency to lengthen the implementation time. It has a tendency to reduce the benefit of having implemented at the first plant and being able to take that as a cookie cutter to the second plant. It wants or needs to own the data. I mean, it's built to be a system of record, and so it's built to store that information. And so it kind of wants to be the center of the manufacturing software world. And it can be a little bit difficult to use as a secondary system that is supposed to address particular functionality in the midst of other applications. With IoT, from the weakness perspective, you're buying a toolkit. There's generally very little out-of-the-box functionality with these systems. And so you have to understand that if you're looking for a solution to a given problem, it's something that once you install the IoT solution, you're going to have to either do some coding yourself or have somebody else come in and do that coding for you to get that configured and set up and ready to go. And so those are kind of the different weaknesses and strengths of the approach of the two different systems. So other common questions that I've gotten from customers in the past: can I build a custom MES with IIoT? And the answer is always, everything is possible with enough time and money. It's certainly possible to replicate any or all of the MES functionality with IIoT, but it probably doesn't make sense to do so given the cost of the development and the fact that the MES software is readily available. And so why reinvent the wheel? So it really depends on how much of that MES functionality you really want to replicate. For needs where only partial functionality, you're just looking at certain core problems, or you don't need the entire infrastructure that an MES system comes with, then it may make sense to kind of build a mini MES with IoT that fits your needs perfectly. But there does come a point where it doesn't make sense to reinvent that wheel. On the flip side of that, I'll get the question from customers: I already have an MES, doesn't that take care of everything? And the answer again is that everything is possible with enough time and money. So it's possible to customize your MES to take care of just about any requirement. But generally, customizing an MES system is more complex than it is to just build a quick IoT app for a given requirement. So it may cost enough to customize your MES to take care of that additional requirement that it just doesn't make sense to do so. And I'll cover some examples of that later on. So when do I use each? And when would I want kind of a blended approach to these solutions? So when I want to use IIoT alone is really when you're looking to implement something small and quick, like our little friend here. And so if the scope is small, or it can be a quick implementation from and you don't have an existing MES and so forth, then it probably makes sense to just tackle that small scope with an IoT solution. It could be that the use cases that you're looking at are not in the core strengths of the MES, in which case to implement an MES and then extend it to cover those use cases wouldn't make a whole lot of sense. There's no need for a system of record on the shop floor. So you're not in food and beverage where you have track and trace requirements. You're not in pharmaceutical where you're in a validated environment. You may have, other systems that are already, recording what you have to from a transaction perspective and so forth. And so you may not have a need for a new system of record on the shop floor, in which case, whatever it is that you're trying to achieve can be done typically in a different way other than an MES system. You have a very strong desire for a custom user interface or workflow or data structures that don't fit the traditional MES model. In that case, you're better off taking a different approach, and an IoT solution is a good way to have a backbone that you can build from fairly quickly. Or it may be that you have best of breed solutions already in place and you really just need to fill gaps and coordinate data flow, and in which case an IoT system is built very much to handle that type of use case. When to use an MES system alone. And fundamentally, when you're looking at a need for a system of record, you have traceability requirements or a full genealogy requirements. An MES system is maybe not required, but it's probably going to be your path of least resistance to get there. So when you want to use an MES system alone, all your desired use cases are available in that core MES. So you don't have any burning value propositions that are required that are outside of that core MES functionality. You really just need that system of record, or you have few to no existing systems in place for quality or planning, or all those things that we looked at on the third slide of the presentation. And perhaps a common system infrastructure is desired across your different facilities. And so there are a lot of really good reasons for buying an MES. And I'm not here to denigrate MES whatsoever. They serve a very valuable role within manufacturing, especially in particular industries, such as the ones that have traceability or genealogy requirements and so forth. And so they're very good at what they do. They've been developed over time and have gone through a lot of iterations of improvement. So if you need an MES system, absolutely get one and put it in place. But what I have found is that very often, even if you have an MES, there are good reasons to look at a hybrid approach. And when a hybrid approach makes sense is when you need those MES functionalities, but it would cost more to customize the MES to fit all the different use cases you have within the plant than it would to use the MES and to kind of extend the functionalities that are provided by supplementing that with an IoT system. And two kind of common scenarios where you have that MES system in place, or you're doing a multi-plant rollout, or you really need the MES as a system of record. But then you have some of the additional requirements that we're going to talk to on some of the subsequent slides. And so the basic idea here in both scenarios is that the MES system is implementation is streamlined by focusing on the core, or kind of vanilla functionality as much as possible. And that way, if you're trying to roll out the MES across 15 separate plants, rather than trying to handle the unique use cases within each facility, you can really implement the core MES and then handle those additional one-off use cases through this other means. So some of the specific use cases that I've seen, and this is going to be by no means a comprehensive list, you've got need to create a UI to display if the unit has passed all the tests and should be sent along to packaging. And you've got information coming in from perhaps operations that are not part of the MES, or you're getting information from an outside system such as a quality system or a LIMS that's not part of the tool, and it would be quicker to implement it and integrate it using the IoT system. There may be sensors that are not part of your manufacturing process per se, that you're not pulling into your MES, such as an environmental sensor for temperature or humidity within your plant, and you want to understand how that is impacting your process. It may be that you want to develop a correlation between your product and your process CPK, and the information for one of those is available outside of your MES. It may be that you want to combine machine data from the PLC with SPC data from separate SPC system to do predictive analysis. Or you have an RFID system that you utilize for like badge tracking. And you want to be able to tap into that system to do spaghetti charting to look at your setup efficiency. And so those are some specific use cases that I've worked on with customers, where to customize their MES to do those things would have been very extensive, but we were able to do it pretty quickly with an IoT approach. A number of vendors that sell MES systems also sell machine learning applications, but it's traditionally not a core part of the standard MES modules. And so there are a number of different use cases for machine learning or artificial intelligence that you could look at, some of which are pretty standard, such as predictive maintenance, and some of which are less standard, such as monitoring lubricants and filters, and doing predictive analysis on when those need to be changed and so forth. Some of them require information from multiple systems that won't be in the MES, such as when you're looking at analyzing your shop floor data to look at warranty predictions. And you need the information from the warranty system to be included within that analysis in order to train the model and so forth. And so even when the MES vendor has their own machine learning capabilities built within there, where you start having to incorporate information from outside, it may be more efficient to use a separate tool to pull that information together. Another place where you can get into this is in custom applications. And so some examples from recent webinars that I've done, you may want to create custom user interfaces for FMEA applications, where you want that to be an ongoing live application that you work with, or value stream mapping, or you want to create a digital management operating system for your organization, or you really want some custom visual controls that pull information from a variety of different data sources and so forth. Or you really want to build an OEE system, what I call the right way. And the possibilities here are really endless, and it's really limited just by your imagination, but it's much easier to build those custom applications in that IoT system typically than you will find in an MES system. And then the IoT system as an integration hub, and I'm not going to kind of read through these because I do have a number of questions that I want to try to get to before my hard stop. And so, there are a number of applications where you're trying to pull information from multiple different systems that are outside of kind of the core manufacturing apps. And so when you're trying to do that, it can often be easier with the IoT system because it's built for those cross application purposes, whereas an MES is generally more inward focused on the data that it owns and so forth. And so with that, some closing thoughts. Again, both systems can provide an awful lot of value where you have need for system of record, or you have a traceability or other requirements. an MES system is, certainly, if not required, very highly recommended. For a lot of those custom use cases, integration use cases, things closer to the edge is something I haven't even mentioned, where you want to build an application that resides basically right at the point of use. That's another place where an IoT approach makes a lot of sense. And so for all of those, a hybrid approach works very well. Where you would want to go IoT alone is where you don't have the system of record requirements, or you already have a lot of best-in-class solutions that you just need to kind of stitch together and supplement. So with that, I'm going to try to get to some of the Q&A questions here. The MES weakness, wanting to own the data, why can it not be a secondary system? It can be, but it's such a heavy system, so broad in its footprint, that if you already have various point solutions in place, to put an MES system in for just a particular use case may not make a lot of sense. And so it generally makes sense as the primary manufacturing system of record as opposed to a secondary one. Let's see, I got a question from Tom McGinnis about historian versus MES versus IoT solution. That's probably worthy of another half-hour talk in itself. Historian is going to capture detailed process information and is often available as a separate module from the MES vendors. And then that information can be blended with the MES data, or you can use it in concert with an IoT solution as well to put even more kind of intelligence into the shop floor and the uses there. Example of an edge application would be something that you need very, very rapid response to. So you want to put an application right at, if not inside of the PLC itself, immediately next to the PLC so that it doesn't have to go through up to the cloud or even back to the server to be processed and then have information go to the machine. So when you're looking to implement, for instance, closed loop solutions and do actual machine control with those. I'm sorry, that's all I have time for. I do have to get to this other meeting, but thank you very much, everybody, for participating. I got some really good questions. I got more questions in the chat. I will try to reach out to everybody that asked a question in the chat. And I'll also mention that this session has been recorded. I'll have it up and running on my websites within the next day or two. And you'll also be able to download the presentation, as well as I'll have basically the transcript of this available as a white paper within the next week or so. Thank you very much, everybody, and look forward to following up with you all. Bye.